Morning, everyone.
Good morning, ma'am.
Good morning, ma'am.
So, we had completed discussing architecture in the previous session, right? So, we'll have a quick recap of whatever we discussed in the previous 5 sessions. So, who will tell me, given an instruction, how will you explain the architecture of 8086? I'll give you two instructions. Somebody explain how you are going to execute that, or how you are going to explain the architecture of 8086 with those those instructions. Okay, I'll write down. Okay, I'll write down few instructions over here. I want somebody to explain the architecture of 8086 using these set of instructions. Okay. One of you explain the architecture of 8086 using these instructions. That means how are these instructions going to get executed on our 8086 processor? Should I call out?
Ma'am, I can try.
Who is this?
Aniruddha.
Yes, Amiru, go ahead.
Yes, ma'am. Ma'am, can you share that screen?
Yes, yes, yes.
Ma'am, first, the 04H05H will be stored in the segment registers. The instructions will be stored in segment registers.
No,
Then
where are the instructions? Where are the instructions? Doesn't
they
matter, it's
come from the
okay.
memory.
Instructions are in which segment of the memory?
Code segment.
How many segments are there in the memory?
Four.
Louder.
Four.
Four segments.
Four
Yes, ma'am.
segments.
Only four segments, or can we say how many segments are there actually there? What is the
Ma'am,
maximum size a segment can have?
At the time,
16,
64 KB a
64
segment
K.
can have. But
64
if the
KB.
user wants,
64 kb.
if
So
the
if
user wants, he can create
64,
more segments.
if 64, suppose we are having segments of all 64 kb, then how many segments are possible?
4.
16.
16 segments are
So
possible.
actually,
Provided,
possible as 16 segments are possible.
provided all segments are of 64 kb size. Otherwise, if the segments are of random size, we cannot say how many segments are there, right? Because the size of every segment can vary. What is the minimum size of a segment?
16 bytes.
What is the minimum size
16.
of a segment? 16 bytes or 10 H.
10
10
at
and
4.
Okay. So where are these where are these instructions stored? They are stored in the code segment of the memory.
Codes.
Now you tell me. Now Anirudh, you proceed. How will we execute?
Yes, ma'am. Then the instructions will go to the prefetch.
That means these instructions have to
6
be
byte queue, yes. In the
prefetched.
queue
So
first.
how does that happen? So how does that happen? What is the form? What is that procedure called as? To prefetch, first you need to
Fetching
calculate
bytes
to
of the
prefetch
instruction
physical address you need to
address.
calculate. To prefetch, you need to calculate the physical address. So you have to start like this. The instructions are stored in the code segment of the memory. For prefetching to happen, first the physical address of these instructions are to be calculated, and that is done by the ALU in the bus interface unit. So what is the formula
Yes,
for
ma'am.
physical address calculation?
segment address into 10H plus offset address.
Segment address into 10H plus offset address. So what is
Offset
there
address.
in the segment register? Segment address. What is there
Segment
in the
address.
offset register? Offset address. So if I'm accessing code segment, which is the segment register?
Offset address.
If I'm accessing code segment, which is the
Yes,
You are
segment
lagging,
register?
ma'am.
ma'am, you are lagging.
Okay. Okay, let me disconnect. Using mobile. Okay. So the question that I asked is, if I'm accessing code segment, then which is my segment register and which is the offset register that I'm going to use for physical address calculation? Am I audible now?
Yes,
Yes,
ma'am.
ma'am.
So
So
did
you
get
heard
the
the question, right? If I'm accessing the code segment, then which is the segment register and which is the offset register that I will use for physical address calculation?
Code segment is the segment register and IP is the offset register.
IP is the offset register. Very good. So now I'll calculate the physical address of the first instruction, move AL, 04H, and then I'll bring it to the 6-byte prefetch queue, right? Now you tell
Yes,
me,
ma'am.
why is the size of the prefetch queue 6 byte?
Because the
Longest
maximum
instruction.
instruction is 6 bytes in a 8086 processor.
Okay. When is the queue refilled?
When
After
one
2 bits.
instruction is after 2
2.
bytes.
After
2 bytes are executed like
2 bytes are free, right?
free. Yes.
After 2 bytes become free in the prefetch queue. Why is it done like that?
Ma'am,
To
the
not waste
maximum.
memory.
Data bus is of 16 bits, so
That's
16
right.
bits equals to 2
Data
bytes.
bus is of 16 bits. That means we can access 2 bytes in one clock cycle. That is why we prefetch only when 2 bytes become free, right? Then that instruction will be forwarded to the control system.
Control
Control
system.
system will do the decoding and then it will give the necessary signals to the
ALU.
ALU and the register. So what will happen?
Yes,
AL
ma'am.
register will release 04H. Then the next instruction will
BL
go through
will
the same procedure. BL will release 05H
05H
and then
and then
ALU
they will
will
get added.
added
Yes, ma'am.
inside the ALU and then the result will get updated in AL
Flags.
register. So
Oh,
this is
yes,
how
AL.
the architecture works. So if you are accessing stack segment, then which segment register will be used and which offset register will be used?
Stack
SS
segment and SP and BP will be used.
Either SS or SP or BP will be used. If you are accessing top of the stack, SP will be used. If you are accessing any random location inside the stack, BP will be used, right? If you are accessing data segment, then DS will contain your segment address and SI will contain your offset address. If you are accessing extra segment, then ES will contain your segment address and DI will contain your offset address, right? So, so this is how your two-stage pipelining works in 8086. So I hope everybody is clear with this. Now we'll proceed to the next topic, which is the flag register of 8086. Okay. I'm going very slow. I'll be speeding up slowly. So today's agenda is to understand the flag register of 8086 microprocessor. So inside the architecture, below the ALU, you saw this component which is called as flag register, right? So this is the flag register of 8086. 8086 has a 16-bit flag register. Okay, how many bit? 16-bit flag register. So you can see here the bits going from F0 to F15. This is the 0th bit for F0, F1, F2, F3, etc., etc., F15. That means the 8086 flag register is a 16-bit flag register. Okay, so what are the important flags in 8086 flag register? There are two different types of flags. Okay, status flags are updated after every normally they are updated after arithmetic and logical operations. Okay, you can see this additional flags, trap flag, interrupt flag, and the direction flag. These are called as the control flags. Trap flag, TF stands for trap flag, DF stands for direction flag, and IF stands for interrupt enable flag or interrupt flag. These are called as control flags, which have a different functionality, whereas the remaining flags, starting from here, CF, PF, AF, ZF, SF, TF, ZF and SF are called as the status flags. So CF stands for carry flag, PF stands for parity flag, AF stands for auxiliary carry flag, ZF stands for zero flag, SF stands for sign flag, and here you have the OF flag, which is nothing but the overflow flag. Okay, overflow flag. So CF, PF, AF, ZF, SF, and OF are called as the status flags, and IF, DF, TF is called as the control flags. Wherever you have XX, that is don't care. Okay, there's no flag as such over there. It represents don't care. So these are the flags in 8086, status flags and control flags. Now let's take each of these individual flags and understand what they mean. Okay, we'll first begin with the carry flag. Okay, so carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, and overflow flag. These are called as the status flags. These are normally updated after arithmetic and logical operations. They may be updated or they may not be updated, but they are normally modified or updated after arithmetic and logical operations, and that is the reason why they are called as status flags. So we'll begin with the first flag, which is the carry flag. Okay, let me take a blank page. Okay, so beginning with the first flag, which is called as carry flag. Now somebody tell me, what is the purpose of carry flag? You might have heard of this term carry flag. What is the purpose of a carry flag? You know what is the meaning of carry, right? If anybody knows what is meant by carry flag, please tell. Am I audible?
Ma'am, it will signal if while doing the AAV operation if a carry has been generated or not.
Okay. So,
Carry or borrow both, I guess.
okay, carry or borrow. So carry flag is set if there is a carry being generated or if a borrow is being generated out of the MSB of the result, right? Let me give you an example. Okay, let me give you a small example. I'm adding two 8-bit numbers. Okay. Now what will happen if I'm adding these two 8-bit numbers? So I've taken just two 8-bit numbers and I'm adding them. So what will happen? 1 plus 1, 0, 1 carry, 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 0, 1 carry, 1 plus 1, 0, 1 carry, 1 plus 1, 0, 1 carry. So what is happening? What is happening here? When I'm doing this arithmetic operation, okay, I'm adding two 8-bit numbers. So in this process, a carry is being generated out of the MSB of the result, right? A carry is being generated out of the MSB. So in this case, what will happen in your flag register? Your carry flag will become set. What do you mean by set? When I say carry flag is set, what do I mean? Carry flag, carry
Status
flag,
is on.
carry flag is 0 or carry flag is 1? Carry flag is 0 or carry flag is
In
1?
this case, carry flag will
Where
become
one.
In this
1.
case, carry flag will be set as a 1. Okay. So the very first flag in your flag register of 8086 is the carry flag. So carry flag is normally set if there is a carry or borrow out of the MSB of the result. Okay. Is it clear? Is it clear, everybody?
Yes, ma'am.
Okay. Coming to the next flag, which is called as the parity flag. So somebody tell me what is meant by parity flag if you know. What is
Ma'am, it will show the status for odd or even binary sets, something like that.
Not no. Somebody else? Any guess? What is meant by parity? You might have learned this in DLCA, this term parity. So what is parity? What is odd parity and what is even parity?
Ma'am, it's a
Number
method
of
used
zeros
for
when
seeing that.
come aloud. Speak aloud.
Ma'am, it is a method used to verify that the message has been sent properly or not. That one by with the help of 1 and 0.
Mm,
The number of
that is
ones,
the application. That is one of the application. But what is actually meant by parity?
the number of ones that are generated during the area operation.
The
The
number of ones. So what do you mean by even parity? Number
Even
even
of
number
ones.
of
parity
ones.
Even number of
is
ones.
one.
Odd parity means odd number
Odd
of ones. Application you said is right. It can be checked. It can be used to check whether whether your message is received correctly at the destination or not. See, if you're sending a message with even parity, and if at the receiver end you are getting a message with odd parity, then it means what somebody has modified in the transmission. So that is an application. But what is meant by parity? Parity is basically about the number of ones. It's just calculated by counting the number of ones in your result. So what is meant by even parity? So if you have this 8-bit number, what is the parity of this 8-bit number? What is the parity of this 8-bit number?
Even.
Even. So parity flag is going to be 0 or parity flag is going to be 1.
1.
Ma'am, could you explain
Parity,
again what parity is?
parity is simply the number of ones in your number. So it can be an even parity. Even parity means number of ones are even. Odd parity means number of ones in your result is odd. So depending upon that, the parity flag will be set or reset. So if the number of ones is odd, parity flag will be
0.
0. And if the number of ones is even, the parity flag will be
1.
0. So in case the number of ones is even, parity flag will be set. If the number of ones is odd, for example, if you have something like this 0 0 1 1 1 0 0 0. So what is here? Here there are only 3 ones, right? 3 ones. So here it is odd case. So if your number of ones in your result is odd, your parity flag will be 0. If the number of ones in your result is even, your parity flag will be 1. That means it will be set. 1 means set. 0 means not set, right? So this is what is meant by parity flag. Is that clear?
Yes,
Yes? Yes. So we are done with 2 flags, carry flag and parity flag. Now moving to the
Ma'am,
next flag. Yes.
ma'am, Sakshi is trying to join the meet, but she can't.
Okay, let me check. Can't see anybody in the waiting room. Ask her to try again, okay? Using,
Ma'am, she is trying.
you might be facing some connectivity issue, network issues. That is why there's no waiting room enabled over here and I can't see anybody to admit. Okay, so carry flag, parity flag, and the next flag is, okay, somebody's there. Next flag is auxiliary carry flag. Okay, so the next flag is auxiliary carry flag. Any guess what would auxiliary carry flag be? Any guess? It's also carry flag only, but it is auxiliary carry. Any guess? Anybody? No? So I'll give you an example, okay? I will take the same example. Okay. Now I'll give you the definition. Auxiliary carry means if a carry is being generated out of the lower nibble, okay? If a carry is being generated from the lower nibble to the higher nibble, then the auxiliary carry flag will be set. Now, what do you mean by lower nibble and higher nibble? Have you heard about this term nibble? Anybody?
4 bits.
4 bits is called as a nibble. So what is the meaning over here? 1 plus 1 0, 1 plus 1 0, 1 plus 1 0, 1 plus 1 0, 1 plus 1 0. So what is happening here? This is your lower nibble, okay? Nibble, N-I-B-B-L-E, nibble. This is your higher nibble. So if you are having an 8-bit number, these 4 bits are called as your lower nibble. These 4 bits are called as your higher nibble. So what is happening here? You can see a carry being generated from here to here, right? Look at this 1. 1 plus 1, 0 and a carry 1. So what is happening here? You have a carry being generated from the lower nibble to the higher nibble. So this is when your auxiliary carry flag will be set. Is that clear? Yes or no? Is there a lag still?
How do we know which nibble is higher and which is lower? Is it a rule that the numbers on the left hand side are lower and on the right hand side are higher?
Then what is this concept of MSB and LSB and all?
Okay, ma'am, got it.
That concept is already there, right? Least significant bit, most significant bit. Similarly, these 4 bits, if you have an 8-bit number, these 4 bits will become your lower byte. These 4 bits will be your higher byte, right? See, sorry, I'm talking about a 16-bit number. If you have a 16-bit number, this is your lower byte. This is your higher byte, right? Same ways, if you have an 8-bit number, if you take 3, 4 alone, 3, 4 is an 8-bit number. So if you have 3, 4 alone, this is 0, 0, 1, 1. This is 0, 1, 0, 0. This is your lower nibble. This is your higher nibble, right? So, if there is a carry being generated out of the lower nibble to the higher nibble, then it is called as the auxiliary carry flag set. So, what is the difference between carry flag and auxiliary carry flag? Carry flag is set if there is a carry or borrow being generated out of the MSB. And what is auxiliary carry? Auxiliary carry flag is set if there is a carry being generated out of the lower nibble to the higher nibble. Is that clear, everybody?
Yes, ma'am.
Nibble means 4 bits. Byte, lower. So lower nibble means the lower 4 bits. If it is a 16-bit number, this is the lower byte and this is the higher byte. Lower 8 bits are called as the lower byte and higher 8 bits are called as the higher byte. If it is an 8-bit number, it is not called as byte, it is called as lower nibble and higher nibble. Right? Now going to the next flag. So we are done with 3 flags, CF, PF and AF. Carry flag, parity flag and auxiliary carry flag. Now coming to the next flag, which is called a 0 flag. So what do you mean by 0 flag? Anybody? When is the 0 flag set? When is
If the number
flag?
is 0.
If the number is 0, that means if the result of your arithmetic operation is a 0. Suppose you are adding 2 8-bit numbers and then you get a result as 0. So that is when the 0 flag is set. If your result is 0. So done with the fifth flag also. The fifth flag is zero flag. Zero flag is said if the result of your arithmetic or logical operation is a zero. Coming to the next flag, which is called as a sign flag. I hope everybody is able to follow what I'm teaching. Yes, now?
Yes, ma'am.
Yes, ma'am.
Yes. Next flag is sign flag. Okay, these are all basic concepts. What do you mean by sign flag? Which bit of, if I'm taking an 8-bit number, which bit represents your sign flag? Or when is the sign flag? How do you find out whether a number is positive or negative?
Ma'am, if it starts from 0, then it's positive, and if it starts from 1, it's negative.
Very good. Who gave the answer?
Ma'am, Akshay.
Akshay. Okay, very good, Akshay. So is it the LSB or MSB that you are looking at?
MSB, ma'am.
MSB, right? If you have an 8-bit number like this, then the most significant bit tells you about the sign of your number. So if this is a 0, you assume that the number is positive. And if this is a 1, then you assume that your number is a negative number. So what is the sign flag? The sign flag simply copies the MSB of the number. So from it will simply, whatever is the MSB, okay, this is the MSB, right? This is the MSB digit. So whatever is the MSB, its sign flag simply copies that. And it assumes that if the MSB is a 0, the number is going to be a positive number. And if the MSB is a 1, the number is going to be a negative one. Okay, I've used the word assume only. I'm not saying that if it is a 0, the number is going to be positive, and if it is a 1, the number is going to be negative. I'm not saying it like that. If it is a 0, we assume that the number is a positive, and if it is a 1, we assume that the number is negative. Now I'll tell you the reason why I'm saying assume. Okay, that is where the importance of sign flag and overflow flag and all comes. See, you know that we have two number systems, signed number system and unsigned number system, right? There are two different types of number system, signed and unsigned. So if it is an unsigned number system, and say I'm talking about 8-bit numbers only, okay? I'm talking about 8-bit numbers. And if I'm saying that I'm using an unsigned number system, what do I mean? I have an 8-bit number and I'm saying that I'm using an unsigned number system. So what am I mean? What do I mean? What do I mean? I have an 8-bit number and I'm using unsigned number system. What do I mean? I mean that all these 8 bits correspond to the magnitude of the number. None of these bits are corresponding, or none of the bits correspond to the sign of the number. So if I'm using an unsigned number system, then it means all these 8 bits represent the magnitude of the number. मतलब इसमें से कोई bit से मुझे number का sign पता नहीं चलेगा. So all the numbers are assumed to be positive only. Okay. So if I'm using an unsigned number system, then all the bits correspond to the magnitude of the number. You know what is meant by magnitude and sign, right? Yes or no? बोलो, कुछ तो बोलो. You know what is meant by magnitude?
Yes, ma'am.
Huh. Now, if I'm using a signed number system, then as Akshay said, this bit, which is called as the most significant bit, or MSB, will represent the sign of the number. That means only these remaining 7 bits correspond to the magnitude of the number, right? This 8th bit, this bit, which is called as the MSB, most significant bit, will represent the sign of the number. Okay. So there are two number systems, signed and unsigned number system. So if you are in unsigned number system, then there's no tension because all the 8 bits correspond to the magnitude of the number. But if you are in a signed number system, this 8th bit, this MSB bit corresponds to the sign of your number. That means only 7 bits correspond to the magnitude. So if I'm saying that my sign flag is, how will the sign flag get information about this sign of the number from this MSB bit? So what the sign flag does is it just copies this bit. Whatever is this bit, it will just copy that. So if it is 1, we assume that the number is negative. If it is 0, we assume that the number is positive. Okay. But It is only an assumption. It is not in actual. Okay, I'll tell you the reason why. Now, let me make this a little bit more elaborate. Okay, if I'm using an 8-bit number, okay, if I'm using an 8-bit number, what is the if I'm using an 8-bit number in unsigned number system, okay, what is the largest number? What will be the largest number? I'm using unsigned number system and I'm using an 8-bit number. What is the largest number that I can have? This one, right? This one, right?
Yes, ma'am.
Yes.
Yes. That means my range will go from 0 to 255. Barabar? If I'm representing it in hexadecimal, then it is nothing but 00H to F of H. This is the case if I am using an unsigned number system. If I'm using a signed number system, then you tell me what will be my range. What will be my range? Tell me.
0 0 to 127. 0 to 127.
0 to 127. अभी साइंड यूज कर रही हूँ, मतलब पॉजिटिव भी हो सकता है, नेगेटिव भी हो सकता है. अगर ये फर्स्ट बिट 0 रहा तो आप जाओ, आपका रेंज रहेगा 0 to 127. अगर ये साइन बिट 1 रहा, मतलब आपका नंबर नेगेटिव है, सो यू विल हैव अ रेंज फ्रॉम दिस साइड आल्सो, राइट? -1 to 128, right? So if your sign bit is a 0, then this will be your range. If your sign bit is a 1, this will be your range. But if I'm writing the hexadecimal equivalent, it will be 00H to 7FH, and this would be -01H to 80H. Barabar? -80H. So if I'm using a signed number system, this will be my range. If I'm using unsigned, it will be from 0 to 255 or 00H to F of FH. If I'm using a signed number system, then my range of my positive numbers will be from 0 to 127 and my negative numbers will be from -1 to -128, right? Or if I'm writing it in hexadecimal, it will be from 00H to 7FH and 01H, -01H to -80H, right? This is the range of the negative numbers. So this simply means that if I'm using an 8-bit signed number, my positive number cannot be greater than 7FH, and similarly, my negative number cannot go beyond -80H. Okay, understand this point. If I'm using an 8-bit signed number, my positive numbers has to fall within this range and my negative numbers has to fall within this range. Anything beyond this, any positive number which is beyond 7F is going to be a case of overflow, and any negative number which is beyond -80H is going to be a case of overflow. Okay, I'll make this clear with an example. Please pay attention because I cannot repeat the same thing over and over again. I'll give you an example. Okay. Suppose I have a number like this. Okay, if I'm using unsigned number system, then what is the hexadecimal equivalent of this? I've written any 8-bit number here. If I'm using unsigned number system, what is this number in hexadecimal?
83H.
83H.
83H. If I'm using signed number system, then you tell me what is this number? What is this number?
-3H.
No. You've learned hexadecimal conversions in the previous semester. How do you represent negative numbers? How do you represent negative numbers? In which form do you represent negative numbers? How do you represent negative numbers? In which form? You've learned this. You've learned this in the previous semester. This is a signed number. That means this bit corresponds to the sign. So that means this is going to be a negative number. Negative numbers are represented in which form? 2's complement form. पढ़ा है last semester में? Negative numbers are represented in 2's complement form. So what is this number actually? What is this number? Tell me. What is this number? Now you should give me the answer. I gave you a hint. It's in 2's complement form. Find out the 2's complement and tell me what is that number. Jaldi 2's complement find out karo and tell me what is that number.
62.
नहीं 2's complement. Jaldi, I'll give you 1 minute.
Seven B.
7?
B.
7?
7.
B?
D, ma'am.
7 B है कि
D.
B है
D.
D, 7D. What is this number? This is 1100. Oh, this is 0 111 plus 1. So this is what? 1. This is what? This is 7. What is this? This is D. So what is your number? Your number is actually minus 7D. Right? Your number is actually minus 7D. So keep this point also in mind, okay, when you're seeing signed numbers, signed negative numbers. Now let me go to the point which I was trying to make, okay. So what is this? This is 7F. What is this? 0, 1. Okay, I'm trying to add these two numbers. Okay, I'm trying to add these two numbers 7F and 0, 1. Now you tell me, so this is the arithmetic operation which is happening inside our ALU. Now you tell me what is the result? What is the result? Result क्या आएगा बताओ मुझे, जल्दी से ऐड करके बताओ. Sit with the book and pen, I told you. What will be the result of adding this? जल्दी जल्दी, इतना टाइम नहीं लेने का.
Ma'am, MSB will be 1 and others 0.
MSB will be 1 and all others 0. Okay, very good. So is this number, is the result which you're getting a positive number or a negative number?
Negative.
Negative है. So what is this? This is actually what? 80H. बराबर? You added 7F के साथ आपने add किया 0, 1 and you got 80H. And you're getting the MSB as 1. That means you will assume that this number is a negative number. बराबर? But आपने add क्या किया? You added two positive numbers. And you're getting the result as a negative number. Is that even possible? Is that even possible?
No.
When you add positive numbers, will you get a negative number? No. This cannot be a negative number. That means this is a case of what you call as overflow. That is why I told in the beginning, sign flag simply copies the MSB. And by looking at the MSB, we assume that the number is negative, or we assume that number is positive, you can conclude. But if your sign flag is a 1, we only assume that the number is negative. The number may not be actually negative. So to find out whether your number is actually negative or not, you have to check this flag which is called as overflow flag. So यहाँ पे हुआ क्या? I told you, when we are taking an 8-bit number, what is the range of our positive numbers? The range of our positive number is from 0 to 127. मतलब 00 to 7f तक, 00h to 7f h. इसके beyond जो जाता है, that is called as an overflow. Same way on the negative side also. On the negative side, your range will be from -1 to -128 or -01h to -80h. Anything that goes beyond this range will be considered as an overflow. यहाँ पे हुआ क्या? 7f is our last number which represents 127. 7f के साथ मैंने जब 1 add किया, so I got 80h. But 80h does not fall within this range. It is what? It is actually an overflow. So your result is not negative. Your result is a case of overflow. तो ऐसे केसेस में क्या करोगे आप सिर्फ साइन फ्लैग देके ये नहीं बता सकते हो कि नंबर पॉजिटिव है या नेगेटिव है. तो नंबर पॉजिटिव है या नेगेटिव है बताने के लिए आपको कौन कौन से फ्लैग देखना पड़ेगा? कौन कौन से फ्लैग देखना पड़ेगा? बोलो. To conclude whether a number is actually negative, which all flags you will have to check?
Carry flag,
Overflow and sign flag, both. Okay, to predict whether a number is actually negative, you have to check both sign flag and overflow flag. Okay, if your sign flag is 0, then there's no problem. Your number is going to be positive only. If your sign flag is a 1, then it means what? Then it means your number can be a negative number. You cannot conclude that your number is going to be a negative number. ठीक है, ये अपना साइन फ्लैग है. और समझो ओवरफ्लो फ्लैग में भी 1 है, तो आप क्या कंक्लूड करोगे? अभी मुझे बताओ. साइन फ्लैग में 1 है, ओवरफ्लो फ्लैग में 1 है, तो आपका नंबर पॉजिटिव है या नेगेटिव है? साइन फ्लैग में 1 है, ओवरफ्लो फ्लैग में 1 है, नंबर पॉजिटिव है या नेगेटिव? इतना बताओ. मत इतना आपने अगर सही बताया, then you understood what I said, what I taught today. साइन फ्लैग में 1, ओवरफ्लो फ्लैग में 1. There can be another case. साइन फ्लैग में 1, ओवरफ्लो फ्लैग में 0. ये साइन फ्लैग, ये ओवरफ्लो फ्लैग. तो अभी आप बताओ.
If there is a 1 in the overflow flag, that suggests an overflow has been there. So
So your number is overflow flag में अगर 1 है, then there is an overflow. Then is your number negative?
it's positive, ma'am.
It is positive. अगर साइन फ्लैग में 1 और ओवरफ्लो फ्लैग में 0 है, then it means your number is actually
negative.
समझ में आया? वही तो मैंने इधर बताया. Taking this example, see here, what are you doing? You are adding 7f and 01, you are getting 80h. और 80h में आपका जो MSB है वो 1 है. MSB 1 है, मतलब साइन फ्लैग में भी 1 ही आएगा. बट आपका ये नंबर नेगेटिव है क्या? 80h नेगेटिव है क्या? 80h negative नहीं है. You have added 2 positive numbers and then you got how can you get a negative number? That means this is a case of overflow flag. तो ये केस में अपना overflow flag में भी क्या आएगा? 1 आएगा. तो आपको ये नंबर का साइन बताने के लिए दोनों को चेक करना पड़ेगा, both sign flag and overflow flag. So when you go and check, sign flag में 1 है, पर आप कंक्लूड नहीं कर सकते हो. Immediately you have to go and check the overflow flag. अगर overflow flag में 0 है, then you can say that your number is negative. अगर overflow flag में 1 है, तो इसका मतलब है आपका overflow हुआ है. Then it means your number is going to be a positive number only. So 1 in sign flag and overflow indicates that your number is positive. And if it is 10 in sign flag and overflow flag, then it indicates that your number is नेगेटिव. समझ में आया सबको? Yes or no? जिनको समझ में नहीं आया, please listen the lecture recordings once again. Okay? So how many flags we have discussed? Carry flag. When is the carry flag set? When there is a carry or borrow out of the MSB. When is the parity flag set? When you have even parity. What is auxiliary carry flag when it is set? It is set if there is a carry being generated from the lower nibble to the higher nibble. When is the 0 flag set? When your result is 0. When the result of your arithmetic or logical operation is a 0. When is sign flag set? Sign flag is simply copied from the MSB of your result. but you cannot conclude whether your number is negative. So if sign flag is 0, you can say your number is positive, but if sign flag is 1, then you have to immediately go and check this flag, which is called as the overflow flag. So if sign flag is 1 and overflow flag is 1, then your number is going to be a positive number. If sign flag is 1 and your overflow flag is 0, then you can conclude that your number is negative. Is that clear, everybody? Yes,
ma'am.
Yes. Now we are left with 3 flags. So we have discussed all the status flags. Now we have to go to the control flags. What is the time? 10:54. Okay, we have time. So we have 3 flags left, which is this trap flag, interrupt enable flag, and direction flag. Okay, so we'll discuss these three flags. Coming to trap flag. Okay. These 3 are called as control flags. Okay. Trap flag is used to set a mode which is called as trace mode. Okay. Trace mode matlab, it is also called as single stepping. Single stepping means, suppose you have a set of instructions and you're going wrong somewhere, your logic is going wrong. Then you can do single stepping on the code. Single stepping means you will execute every single instruction and then you will go and check the status of your registers. समझो आपने add AL, BL किया और आपको जो result मिलना चाहिए था वो आपको नहीं मिल रहा है. Then you can immediately go and check what is there in AL, what is there in BL, what is the result that is getting updated in AL. You can go and check the status of the flags also. So after every step, you can go and check the values of the registers and flags to find out where you are going wrong. Okay. So examining that, executing every instruction, then going and verifying what are the status or what are the values that are getting updated in the registers to find out where you are going wrong. Okay, is called as trace mode. It's called as single stepping. So this trap flag is a flag which is used to enable single stepping. मतलब अगर आपका एक set of instructions है which you are executing and say at somewhere here you're going wrong and you want to do single stepping. So what you will do, you will set trap flag as 1. So the moment you set trap flag as 1, what will happen? After every instruction, your MUP will stop. Okay, your MUP will stop means you can go and check out the status of the registers and flags. And then if that is fine, you can go to the next step. It will execute the next step. So after every step, your microprocessor will actually stop. Okay, this is called as single stepping. So अगर यहाँ तक आपको single stepping करना है, तो आप क्या करोगे? ट्रैप फ्लैग को 1 करोगे और जैसे ही यहाँ आओगे आप ट्रैप फ्लैग को वापस 0 करोगे. तो यहाँ पे वापस 0 किया मतलब this will normal execution will resume from here. So यहाँ से यहाँ तक क्या होगा? Single stepping होगा. What is meant by single stepping? Executing every instruction one by one, and then you examining these. You can examine the status of the registers and flag. This is basically done to find out where you're going wrong. Okay. Just like you can do debugging in various compilers, it is very similar to that. So what is the purpose of trap flag? Trap flag is used for executing in trace mode or doing single stepping. Single stepping means executing every instruction one by one and then examining the status of the result in the registers and flag. Is that clear, everybody? So TF equal to 1 means single stepping mode is enabled. TF is equal, when you make TF is equal to 0, it means you are disabling the single stepping mode. Clear, everybody?
Yes, ma'am.
Okay. The next flag is called as interrupt enable flag or interrupt flag in short. Okay. Okay. If interrupt flag is equal to 1, it means your MUP should recognize the interrupts. See, suppose there are a lot of peripheral devices which are connected to your system. Okay. And if you do not want your MUP to be interrupted, what you will do? You will make IF flag 0. So if interrupt flag is 0, then there cannot be any interrupt. That means interrupts are disabled. Your MUP cannot be disturbed by any other peripheral device. So if you're making interrupt flag is equal to 1, then it means MUP will accept or MUP will halt its current operation and then it will service the interrupts. So what is the purpose of interrupt flag? Interrupt flag is equal to 1 means you are enabling the interrupts. Your MUP will be interrupted by the request from external or peripheral devices. If you're making interrupt flag equal to 0, then it means interrupts are disabled. Your MUP will not be interrupted or disturbed by the interrupts from the various peripheral devices. That is the purpose of this interrupt flag. So IF equal to 1 means interrupt enabled. IF equal to 0 means interrupts disabled. Okay, interrupts means request from other external peripheral devices for the service of the MUP. Okay, MUP might be currently executing some program, right? So if interrupt flag is 0, that means it will not entertain any request from other devices which are connected to the MUP. If interrupt flag is enabled, then it means it will stop. Suppose an interrupt comes from the keyboard, it will stop its current execution. If that interrupt is a very high priority interrupt, it will service that interrupt, and then only it will continue with the execution of the remaining program. So this is the purpose of interrupt flag. Is that clear?
Yes, ma'am.
And the last flag is called as DF flag or direction flag. Okay, direction flag is basically used when you are executing string instructions. Okay, string instructions. So you can go in two directions. That is, you can use string instructions in auto decrement mode or auto increment mode. Okay, so if DF is equal to 1, it means auto decrement. If DF equal to 0, it means auto increment. Okay, see, if you have a string like apple, if you want to scan from left to right, or say you want to scan from right to left. So if you want to scan from left to right, you will go in which mode? Auto increment. You will be incrementing the addresses. You will be scanning from, if you want to scan from left to right, you will be going in auto increment mode. Suppose you want to go in the reverse direction. You want to scan from right to left. Then you will be going in auto decrement address mode. Okay. So when you are, particularly when you're working with string instructions, you can enable this direction flag. So to just scan in the normal direction or to scan in the reverse direction. That means you to go in the auto increment address mode and to go in the auto decrement address mode, you can make use of this direction flag. Okay, so it is just basically to decide in which direction, or you want to scan in incrementing address manner or decrementing address manner, you can enable this flag. So DF equal to 1 means you will be going in the auto decrement address mode, and if DF equal to 0, you will be going in the normal mode, that is auto increment mode. So that is the purpose of this flag, which is called as direction flag. Is that clear?
Yes, ma'am.
This is basically used in the case of string instructions. Now you people give me a quick recap of all the flags in the flag register. What is carry flag used for? Or what is the purpose of carry flag? When is it set?
When
When
there
is
is
it set?
in MSB.
When there is a carry out of the MSB. MSB मतलब last bit, 8th bit. अगर 8th bit number है तो 8th bit से अगर एक carry आ रहा है तो carry flag set होगा. Parity flag will be set when it is even or odd parity.
even
Even parity है तो parity flag set होगा. Auxiliary carry कब set होगा? Auxiliary carry flag कब set होगा?
जब
higher
Lower nibble to higher nibble. मतलब lower nibble मतलब 4th bit. आपके 4th bit से 5th bit में अगर एक carry आ रहा है ना, तब see lower nibble. This is the 4th bit. यहाँ पे आपका higher nibble है 5th bit. तो 4th bit से 5th bit में एक carry आ रहा है. That is from the lower nibble to higher nibble. If you are getting a carry, auxiliary carry flag will be set. Zero flag अगर आपका result 0 है. साइन फ्लैग का कोई तो बताओ, करेक्टली बताओ. हाँ, करेक्टली बताओ, साइन फ्लैग कैसे यूज होगा?
अगर MSB 0 है तो साइन फ्लैग पॉजिटिव रहेगा, और अगर MSB 1 है तो वो नेगेटिव.
MSB 1 है तो नेगेटिव है क्या?
It will
Assume
check
करता हूँ.
auxiliary.
Depends
मतलब
on the
assume
source
करते
of flag also.
है. हाँ, एज्यूम करते हैं कि नेगेटिव है, बट एक्चुअली नेगेटिव है क्या?
नहीं,
एक्चुअली नेगेटिव है या नहीं समझने के लिए किसको
ओवरफ्लो चेक करना पड़ेगा.
ओवरफ्लो चेक करना पड़ता है. अगर ओवरफ्लो 0 है तो हमारा नंबर एक्चुअली नेगेटिव है. अगर ओवरफ्लो 1 है तो हमारा नंबर नेगेटिव नहीं है, हमारा नंबर इज अ केस ऑफ overflow. That means it is going to be a positive number only. Okay. हाँ, अभी next flag. So these much are called as a status flags. Trap flag का purpose क्या है? What is the purpose of trap flag?
Executing every step and examining the result.
It is called as single stepping. Okay, to do single stepping. What is the purpose of interrupt flag? Enable, to enable interrupts. IF अगर 1 है तो interrupts enabled है. TF अगर 1 है तो single stepping enabled है. और DF अगर 1 है तो is it auto increment or auto decrement?
Decrement.
Auto decrement.
Decrement.
DF अगर 0 है तो normal है. DF 1 है तो special है. मतलब auto decrement mode में जा रहा है. Okay, so these are these. So your flag register in 8086 is a 16-bit flag register. Okay, it's a 16-bit flag register, out of which few are don't care and few are reserved. Okay, so we'll wind up for the day. We'll continue in tomorrow's session. All your lecture recordings and notes, PPT, lecture PPT still now are uploaded. If there is any section which is not clear to you, revisit the lecture recordings. Those who have not marked your attendance in the chat window, please mark your attendance.
मैम मैम मुझे वो मिनी प्रोजेक्ट का नोटिस जो आपने भेजा था ना कल, उसके बारे में पूछना था.
एक मिनट लेट मी जस्ट स्टॉप रिकॉर्डिंग. वो मैंने नहीं भेजा था. योर मिनी प्रोजेक्ट कोऑर्डिनेटर इज दीपक काचने सर. Has everybody marked your attendance? Let me just stop recording.